Hey, today we are putting it all together and talking about weather. So today is all about fronts. And a front is just simply a collision of two air masses. I know it was a while ago, but we talked about air masses, these big clumps of air that have the same characteristics throughout the entire thing. I'm talking like maritime, tropical, continental, polar, those air masses. And when these two air masses collide, they don't mix together. It's very similar to oil and water. They produce a boundary and they don't mix. And that boundary is what we call a front. And these fronts can be very small, just a few kilometers wide to potentially hundreds of kilometers wide. And again, the big idea is that there's no mixing of air. So what are the different types of fronts? We're going to start with a warm front. And with a warm front, fronts are really just named for what type of air you're left with. So in the case of a warm front, we're replacing cold air with warm air. So our warm air mass is pushing cold air out of the way. And if you think about that for a second, this cold air and warm air, you have to think about densities, right? Cold air is going to be more dense, it's going to be heavier, it's going to be slower, compared to a warm air mass that's going to be less dense and it's going to want to lift into the atmosphere. And it's really just going to have a hard time pushing that cold air out of the way. So with these warm fronts, you end up having this very, very gradual slope or boundary. And the warm air, as it's trying to push over this cold air, kind of topples on top of it. And that causes some of that warm air to gently rise on this slope, this wedge that's produced. And when it rises, it expands and cools and condenses, forms clouds, and creates light precipitation. So a warm front is usually preceded, the weather that comes before the warm front is usually like a very overcast day or two with light precipitation. And if you think about it, you can probably remember a day or two or three that have been pretty overcast with on and off rain. And that was a warm front. And after that warm front passes by, you're left with warmer air and clearer skies. And these warm fronts are usually very slow moving. And warm fronts don't usually produce any severe weather at all, just because the lifting of air is very gradual and slow at that boundary. The next type of front is a cold front. And so again, a cold front means that cold air is replacing warm air. Warm air being less dense, wanting to be lifted into the air. The cold air mass being more dense, wanting to stay on the ground. And so when these two air masses collide, the cold air is going to very easily and very rapidly lift up this warm air mass. And so a cold front has a very steep boundary between these two air masses, and that rapid lifting of air causes the air to rise and expand and cool and condense and form clouds, and this is where we get severe weather. Because of how rapidly all of this warm air is lifted all at the same time, we end up getting things like thunderstorms or potentially tornadoes. Any sort of severe weather that we talk about is usually associated with a cold front. And these cold fronts, because the cold air has such an easy time moving the warm air out of the way, they travel faster. And they make these really tall clouds that form, and again, this is where we're going to have heavy precipitation, usually just over a short land area. It'll be very intense for a short period of time and then it'll be over. Unlike a warm front that has kind of that drizzly day or two before the front passes. And again, I think if you think back in your memory, in your past, you probably remember one of these cold fronts coming through. For me, it always reminds me of the middle of the night, where you're sleeping really, really well, and then all of a sudden, in the middle of the night, you're woken up by extremely heavy rain and thunder and lightning, but just for a short period of time. And then the storm passes, and it's calm, and you fall back asleep. That right there was a cold front moving over your house. Another type of front is called a stationary front. And this is where two air masses are kind of passing each other by like cars on a rope. They're moving opposite directions. They do bump into each other a little bit, but more or less they're moving horizontally past one another. With a warm front and a cold front, one air mass is pushing the other out of the way. In a stationary front, it's called a stationary front because it doesn't usually move. Duh, it's stationary. And the type of weather you get really is dependent on the type of air masses and also how much they're interacting. And sometimes those air masses, they bump into each other a little bit more as they're passing each other. And then you'd get some more air lifting and rising, expanding, cooling, condensing, forming clouds, and some precipitation. But other times, those air masses, they're not really too aggressive, they don't bump into each other a whole lot, and you might not get weather at all. The very last type of front we're going to talk about is an occluded front. And this one is like the mother of all storms. It is the most intense rain you're going to get over, this time, a large land area. And take a look at these diagrams I'll throw up and just see the progression of an occluded front. It starts off with a cold front chasing down a warm front. Warm fronts are slower, cold fronts are faster. Eventually that cold front will catch up. And what I want you to see here is all of the warm air on the surface of Earth trapped between the cold front and warm front. You see all that warm air? That's what makes these so different. Because as that cold front starts to catch up to the warm front, all of that warm air that was trapped in the middle all gets lifted at the same time. And as it gets lifted, it rises and expands and cools and condenses and forms clouds and heavy precipitation. So an occluded front has heavy precipitation over a large land area. There's going to be a lot of people getting a lot of heavy rain. It's going to last for a while. Unlike a cold front, which is just heavy precipitation, but for a short time on a small area of Earth's surface. And since these occluded fronts, they have kind of a specific setup necessary here, they're not quite as common as our cold fronts or warm fronts. Hey, that's all we have today about fronts. Please make sure you're drawing some good diagrams, and please at any time if you have any questions, make sure you pause the video, you come up to Mr. Z, and you ask some questions, okay? Thanks.